Okay, welcome dear students. Today we are going to start about the Newton's laws of motion. As we know that there are about 3 Newton's laws of motion, which is the first Newton's law of motion, second Newton's law of motion, and the third Newton's law of motion. But in order to understand these laws well, there are some basic terms that we must be aware of or aware with them, so as we can understand these laws very well. Among of those terms is what so-called inertia. The term inertia just simply means the ability of a body at rest to resist motion, or a body in motion to continue moving in a straight line when abruptly stopped. That is the exact definition of the term inertia. Then coming to the first Newton's first law of motion, this law of motion is sometimes referred as the law of inertia. You may ask yourself why Newton's first law of motion is sometimes referred as the law of inertia. Let's check how it is being stated, then so as we can relate with the definition of inertia. Then we can track if there is any correlation between these two explanations. Newton's first law of motion states that every body continues its state of rest or uniform motion in a straight line if there is no external force acting on it. Then on looking well and describing the statement of Newton's first law of motion well, and coming back to the definition of inertia, you will see that there is a correlation, and that is the reason why Newton's first law of motion is sometimes referred as the law of inertia, because it talks or it speaks or it tells us the information about the inertia. Then before going away to this Newton's second law of motion, we have to understand the meaning of the word momentum. The word momentum in physics just simply means the product of mass of a body and its velocity. And the SI unit of momentum is simply kilograms meter per second. This SI unit is derived from this equation, as here m represents momentum, which is equal to small m, which means mass of a body, times velocity. This means velocity of the body. So this means that in order a body to have momentum, hence must possess some mass and also must have a certain velocity. Going forward, the magnitude of momentum of a moving body tell us about the amount of external force required to stop the body. Also, it shows the amount of distraction if that moving body could impact or collide with another one. So therefore, if we know the momentum of a body, we'll be able to know what amount of force required to stop that body from its motion. You see? Then the idea of momentum is explained in the Newton's second law of motion. So we are being told that here the idea of momentum, as we have defined here, as also being included in Newton's second law of motion. Let's check Newton's second law of motion. We have been told that Newton's second law of motion is sometimes referred as the law of force. You may ask yourself, why the law of force? Why Newton's second law of motion is sometimes referred to be the law of force? Let's check how it is being stated. Newton's second law of motion, it states that the rate of change of linear momentum of a body is directly proportional to the applied force, and it takes place in the direction of the force. So from this statement here, we see there is the term linear momentum, and we have already seen the definition of momentum there above. So let's continue Newton's second law of motion. Suppose force F acts on a body of mass m for time t. This force causes the velocity of the body to change from initial velocity small u to final velocity v dash in that interval t. This t means time. Therefore, as explained here, we are being told that assume that there is a certain force which acts on a body of mass m at a certain time. Then this force causes the velocity of the body to change. That extent, whenever we apply external force to a body, whether it is moving or it is in a stationary state, there will be a net movement that we will make to that or to a particular object or to a particular body. Then the change in momentum will be, now the change of momentum will be m meaning mass of that body, times final, v dash means final velocity, minus mass of the body times the initial velocity. So this term simply means the final momentum, and the final momentum, and this means the initial momentum. Why? Because here we have multiplied the mass of the body with the final velocity, and here we have multiplied the mass of that body with the initial velocity. Therefore, taking the difference between the final momentum and the initial momentum of a body is what we obtain here is what we call the change in momentum. I think we are together there. Then, from the second Newton's law of motion, as stated there, we say that the rate of change of momentum, but mathematically the rate of change of momentum is expressed as this one. As we know that this numerator here means change in momentum, mathematical representation of the change of linear momentum, and here t means the rate at which the momentum is changing. Are we together? Then, from Newton's second law of motion. Now, from Newton's second law of motion, which states that the force, we know that the rate of change of force is directly proportional to the rate of change of momentum. Therefore, the mathematical representation of the Newton's second law of motion is this one. We see here the force is directly proportional to the rate of change of momentum. Let's name this as equation 1. Now, rewriting equation 1 above, we put out this m because it appears to these both two terms. Then the above equation 1 becomes in this form. M is being factored out there, so we remain with final velocity minus initial velocity over t, which this term simply means acceleration. Therefore, we substitute this expression, we see acceleration, which acceleration being represented by a letter a. Therefore, equation 2 becomes f is directly proportional to m a. A is this one, which is this one. So the equation becomes f is directly proportional to m times a, where f is the force acted on a body, m is mass of a body, and a is the acceleration of the body. Then the equation 4 above is a mathematical representation of the Newton's second law of motion. But on removing proportionality sign, this one proportionality sign, after removing proportionality sign, we now introduce the constant k. Therefore, the equation 4 becomes f equal to kma, but we assume the value of k to be equal to 1. Then the final expressions become f equal to ma. This is an official representation of Newton's second law of motion. This equation is more useful in different calculations concerning with Newton's laws of motion. Now, coming to the Newton's third law of motion, we are being told that another name of Newton's third law of motion is the law of action. Then also here you may ask yourself, why this law is referred as the law of action. Let's check on how it is being stated, then so we can get the reason. Newton's third law of motion states that in every action there is an equal and opposite reaction. It states that in every action there is an equal and opposite reactions. I think there you are understanding. If you are not understanding, there is a drawing here. I hope it will help you. Then consider a book pressed on the top of the table as is shown in the diagram below. Now suppose we have a table here and we have our book and we have pressed that book on the table here. So when you look close to this drawing, you see that there are two forces acting here. The first one is the force due to the weight of this book, which is mg, directing where? Downward. And there is this force R, known as the normal reaction. Normal reaction is the force from the table which supports this book. Therefore, there are two operating forces here. The force due to the weight of the book, which is directing downward, and the force from the table supporting this book, which is directed upward, and it is known as normal reaction. Therefore, we are being told that if a body of a mass m is pressed on a table as is shown above, the body presses on the surface of the table with a force equal to mg. Meanwhile, the table supports the body with upward force, as I have explained you earlier. The force which is weight of the body is called the action of a force. Therefore, this force which caused by the body is called the action of a force. But while the upward force provided by the table, this one upward force, is known as the reaction force. This one is known as the reaction force, and this one is known as what? The action of force. So we see here there are two forces. These forces are just equal in magnitude, but just opposite in direction, because one is pointing upward, another one is pointing downward. So according to the Newton's third law of motion, there will be no net movement of the object here, because the two forces have balanced together and they differ in direction. Therefore, the net movement of the object is 0. Therefore, that marks the end of our lecture of today. The next lecture we will solve the numerical examples about Newton's laws of motion. Please don't forget to subscribe so as you can learn a lot from me.